Okay, this video is solving a system of linear equations using elimination with multiplication and addition. Hopefully you have looked at the previous video that I have posted on solving a system of linear equations using elimination with addition. So along those same lines, we sort of got into this when we distributed the negative or the -1 through so that we were able to use elimination. Again, we're still just solving algebraically, solving a system algebraically. And remember, the two methods are using substitution and using elimination. And we talked about the fact that to use substitution, you really want it to be pretty straightforward. You want it to already be solved for a variable, like we may want it to say x equals 3y minus 9. Or you want it to be an equation that's fairly easy to solve for a variable. For example, if maybe we had 7x minus y equals 5, it would be pretty easy to solve for that y, and you wouldn't end up with any fractions. But if you look over here at this system, if we were to solve for any of these variables, here we'd have to divide by 5 or divide by 4. In any of these cases, we'd end up with fractions and it would get a bit messy. It is possible to do, but usually elimination is going to be the better option for a problem like this. So the next thing we look for when we have this system is we look to see if there are any variables that will eliminate immediately if we were to add the two equations. And if we were to add these two equations, we would get negative 10x. If we were to add these two terms, we'd get negative 10x. And if we added these two, we would get positive y. So we wouldn't end up eliminating any of our variables. So then we need to manipulate, or I once had a professor that told me that we need to finagle these. But what we're going to do is we are going to see what we could do to create terms that are inverses of each other, like a positive 4x and a negative 4x. So we can do this with either the x's or the y's. In this problem, just looking at it, there's not one that's any easier than the others. Actually, let me take that back. If you look here, these are the same sign. But if you look at the y terms, they are already opposite signs. So let's go ahead, let's manipulate the y's so that we can make those cancel out. Because the signs, we don't have to worry about the signs because we already have a plus, a positive, and a negative. So let's choose, I'm going to choose the y values there. So what I'm going to do is I'm going to look for the least common multiple of 5 and 4, and that's going to be 20. So if I multiply this entire equation by 4, and if I multiply this entire equation by 5, that's going to give me a positive 20y here and a minus 20y here, and then those in turn will cancel out. So let's do that. And again, the reason I decided to choose my y's is because there was already a plus and a minus. And then I just needed to figure out what would be my least common multiple between 5 and 4, which would be 20. And so I'm going to figure out I need to multiply the 5 times the 4 and the 4 times the 5. And that often happens that you do just multiply by multiply them by the coefficients of each term. So when I do this, this is going to give me negative 12x plus 20y equals to 36. And this is going to give me a negative 35x minus 20y equals to 105. So as you can see, this is doing exactly what we wanted it to do. Now we have a term that when we add the two equations will be eliminated. So when we add these two equations, now we end up with a negative 47x equals, what's that going to be, 141? And then divide both sides by negative 47. And we end up with x equals to a negative 3. Now hopefully you guys are getting the hang of this, and you know once we get the x value, we need to find the y value. And so I can substitute this into either equation. I'm going to substitute it into the top equation just out of habit. Plus 5y is 9. This is going to give me a positive 9 plus 5y equals to 9. Subtract 9 from both sides. I get 5y is 0. And if you recall, if you have 0 and you divide it by 5, you still have 0. So that tells me the ordered pair negative 3, 0 is the solution to this system of equations. So you can feel good about that, but I would strongly suggest that you still go back and check it. So I'm going to substitute into the first equation, plus 5 times 0, and we want to know, does that give me 9? Negative 3 times 3 is 9, 5 times 0 is 0, and it does indeed give me 9. Substitute into the second equation, negative 7 times negative 3 minus 4 times 0. We want to know, does this give me 21? Negative 7 times negative 3 is indeed a positive 21 minus 0, which does indeed give me 0. Now notice this is just what I got when I checked. My answer is the point negative 3, 0, which is the solution to this system, which means that if we were to graph these two lines, they would intersect at the point negative 3, 0. Okay, let's look at one more example. This one, I think hopefully you guys are able to look at problems now and say, well, substitution would not be easy to do with these problems. So let's use elimination. There are no terms that will eliminate easily here by adding, so we will need to use multiplication. And neither of these terms is easier because we're going to have to worry about the signs anyway. So I'm just going to go ahead and eliminate my x's. So the least common multiple of 5 and 7 is going to be 35. And I need one of these to be positive and one of these to be negative. So if I multiply this by a negative 7, negative 7 times negative 5 is going to give me a positive 35. And if I multiply this, if I distribute this by 5, 5 times negative 7 is going to give me a negative 35. And that's my goal. I want these terms to be able to cancel out. So let's do that. So let me clear that ink there. So I'm going to multiply this by a positive 5. And again, the reason I'm multiplying one by a negative and one by a positive is because I need for their signs to be different. So when I distribute, this is going to give me a positive 35x minus 28y. And when I distribute here, this is going to give me a negative 35x plus 30y equals to 60. And hopefully you guys are catching that I made a mistake there. When I distribute, what I just said was we need to distribute to every single term. So that's going to give me my positive 35x minus 28y, and this should actually be a negative 70. Just making sure you guys are staying on your toes. Alright, so here, 35x minus 35x, these do cancel out and give me 0. A negative 28y and a positive 30y gives me a 2y. Negative 70 plus 60 is going to give me a negative 10. Divide both sides by 2, and y is negative 5. Now once you've solved for 1, we're on our way. This gives me negative 5 for y. Let's substitute it back into either equation. I'll substitute into the first equation. I get negative 5x plus 4 times negative 5 equals 10. And this is going to give me negative 5x minus 20 is 10. Add 10 to both, or excuse me, add 20 to both sides. Get 30 and divide by negative 5, and x is a negative 6. So that gives us our solution to the system. You could substitute it back in to check. And even if you don't do this on paper, it's a good idea to do it in your head just to make sure that you are on the right track. And that's 4. So that's going to give me, negative 5 times negative 6 plus 4 times negative 5. And we want to know, does that give us 10? So that's going to be 30 plus a negative 20, which is indeed 10. And then we substitute into the second equation. And the question here is that going to give me 12. Negative 7 times negative 6 is 42. 6 times negative 5 is going to be a minus 30, plus a negative 30 or minus 30, and that is indeed 12. So we can say with confidence that our answer is correct and that that is the solution to the system, which actually means if we were to graph these two equations, they would intersect at the point negative 6, negative 5.